This is just a short concept bite video for the Maths for Chemists course on accuracy and precision. Sometimes it's easy to confuse what we mean by accuracy and precision, but these three images that I'm going to have here hopefully make clear the difference. Something can be accurate but not precise by having a large range of values associated with it, but they're all collected around a mean value which is close to what we would expect to see. Usually when we have low precision instrumentation, we should have something which is accurate but not precise. I can also have something which is both accurate and precise, where my data is all closely huddled together and it all is close to the value we would expect from that recording, from that measurement. Finally, I can have something which is precise but not accurate. The data is all huddled around a single point, but it's not the point that we would expect or perhaps necessarily want from our data collection. This often is the case that we have to consider when people are reporting data to have a large number of significant figures, but those significant figures are there without good cause, without good reason. Having the appropriate number of significant figures is a recognition of how well we think we know the measurement, the precision of that measurement. For values without a reported error, it's assumed that the uncertainty is reported in the final digit. Here I give three different values for delta H of a reaction, and we can see that they all have different numbers of significant figures. In the first one, minus 98, I'm assuming that my value lies between minus 97 and minus 99 kilojoules per mole. However, if I move over to the far side, the one with four significant figures, two decimal places, here I'm assuming that my value lies between minus 98.31 and minus 98.33 kilojoules per mole. Reporting too many significant figures is not being precise, and I'm going to go so far as to say is outright wrong. We can't increase our accuracy of a calculation just by using significant figures that come off a calculator if the initial measurements and data do not support them. Fundamentally, there is a limit to how well we can measure something. The uncertainty or the error can be calculated from the spread of the measurements taken, but quite often, particularly if we're using equipment, we don't go on to consider that. We should always try to use equipment as well as possible to make sure it is as precise as the equipment is built to be. One thing to remember when we talk about uncertainty or error, it's not that anything is wrong with our measurements. Fundamentally, data will always take on a spread of data, and the data that we've collected should always be right if we've done the experiment properly. I hope this helps. If you've got any questions, please ask.